March 15, 1945. Major Klaus Weber pressed his field glasses against his eyes, watching in stunned silence as American sappers moved across the lethal minefield his engineers had spent 3 weeks perfecting. Each explosive device had been placed with mathematical precision, creating an impenetrable barrier that should have stopped any advancing force for months. Weber had calculated it himself. Clearing such a dense field using traditional methods would require at least 200 man-hours per acre, assuming the enemy even possessed adequate mine detection equipment. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you. Yet somehow, impossibly, the Americans were advancing at a pace that defied every principle of military engineering Weber had learned at the prestigious Dresden Military Academy. His meticulously crafted defensive maze, designed to channel attackers into killing zones while consuming weeks of their precious time, was being systematically dismantled in mere hours. The morning mist rising from the Rhine Valley carried with it the sound of American machinery, not the careful, methodical probing he expected, but the steady rhythm of industrial-scale clearance operations. Weber lowered his binoculars and reached for his field telephone, his hands trembling not from the cold March air, but from the implications of what he was witnessing. 3 months earlier, German High Command had assured him that American engineers were poorly trained civilians in uniform, lacking the technical expertise and tactical patience required for complex obstacle warfare. "They fight like cowboys," his commanding officer had dismissed them, rushing forward with more enthusiasm than skill. Now, as Weber watched entire sections of his defensive line vanish beneath the systematic advance of American combat engineers, he began to understand that everything he had been told about his enemy was catastrophically wrong. The German Military Engineering Corps had built its reputation on precision, methodical planning, and technical superiority. For nearly 6 years of warfare, these principles had proven themselves against British, French, Soviet, and countless other military forces. German pionieri were renowned throughout Europe for their ability to construct impregnable defensive positions, their mastery of explosives, and their systematic approach to battlefield engineering. When American forces first appeared in significant numbers during the Normandy landings, German military analysts were confident that their engineering expertise would provide a decisive advantage in defensive warfare. This confidence was rooted in more than mere professional pride. German military engineers had pioneered many of the techniques that defined modern combat engineering. The systematic use of minefields as force multipliers, the integration of obstacles with natural terrain features, the development of specialized explosive devices designed to defeat specific types of equipment, all of these innovations bore the stamp of German technical ingenuity. By 1945, German defensive engineering had reached a level of sophistication that their leadership believed would be impossible for any enemy force to overcome quickly. Major Weber himself embodied this tradition of technical excellence. A graduate of the Technical University of Munich before the war, he had spent 5 years refining the art of defensive engineering across multiple fronts. His expertise in mine warfare was considered exceptional even by German standards. The minefield that now lay between his position and the advancing Americans represented the culmination of his professional knowledge. A carefully orchestrated combination of anti-personnel devices, anti-tank mines, booby traps, and dummy positions designed to create maximum confusion and delay. The density of Weber's minefield exceeded anything previously attempted in the European theater. Every square meter had been surveyed, measured, and precisely plotted. Anti-tank mines were buried at exact intervals, calculated to defeat American Sherman tanks, while smaller anti-personnel devices filled the gaps between them. Tripwires connected to artillery shells created additional hazards for infantry attempting to probe the defenses. False gaps in the minefield would funnel attackers towards concealed machine gun positions and pre-registered mortar targets. Weber had spent weeks perfecting the psychological aspects of his defensive system as well. Obvious dummy mines were scattered across the front edges of the field to create the impression of hasty, amateur work, while the real killing devices lay deeper within the complex. Signs in broken English warned of danger zones that were actually the safest paths through the minefield, designed to create fatal confusion among enemy engineers. The entire system was a masterpiece of military deception, incorporating lessons learned from years of combat experience. German confidence in their engineering superiority was reinforced by intelligence assessments that consistently underestimated American technical capabilities. Reports from the Eastern Front described Soviet engineers as brave but crude, often accepting enormous casualties to achieve their objectives through brute force rather than technical finesse. Initial encounters with British forces in North Africa and Italy had suggested that Allied engineering capabilities, while competent, followed predictable patterns that German defensive measures could effectively counter. American combat engineers, according to German intelligence analyses, represented an even lesser threat than their British counterparts. Military assessments described them as hastily trained civilians lacking the professional military education that characterized European engineering corps. Their equipment was presumed to be adequate but not exceptional, their tactics straightforward but unimaginative. Most importantly, American forces were believed to lack the patience and tactical discipline required for the methodical work of mine clearance under fire. This assessment seemed to be confirmed by early encounters with American forces in Sicily and southern Italy. German defensive positions had indeed slowed American advances, forcing lengthy delays while engineers cleared obstacles and established safe passages for following forces. These initial successes reinforced German confidence in their defensive engineering doctrine and contributed to a dangerous underestimation of American adaptability and innovation. Lieutenant Colonel Heinrich Brenner, Weber's immediate superior in the 347th Pioneer Battalion, had personally briefed his officers on what to expect from American engineering capabilities. Brenner was a veteran of campaigns in Poland, France, and Russia, a professional soldier whose expertise had been forged in the crucible of actual combat. His assessment of American capabilities was based on careful study of intelligence reports and personal experience with Allied forces. According to Brenner's analysis, American engineers could be expected to approach the minefield using standard British procedures modified for their own equipment and tactical doctrine. This would involve careful reconnaissance using handheld metal detectors, systematic probing with bayonets or specialized tools, and methodical clearance of safe lanes through the obstacle belt. Such operations, conducted under the constant threat of German observation and artillery fire, would require days or even weeks to complete successfully. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means the mathematics of mine clearance seemed to support this assessment. Each mine required individual detection, careful excavation, and either removal or controlled detonation. A skilled engineer working under ideal conditions might clear perhaps 20 mines per day. The complex nature of Weber's defensive system, with its multiple layers of real and false obstacles, would slow this pace considerably. Factor in the stress of working under enemy fire, the need for extreme caution to avoid casualties, and the time required for command decisions about tactical alternatives, and the timeline for breaching the position stretched to months rather than weeks. Brenner had calculated that Weber's minefield represented at minimum a 6-week delay for any attacking force. This estimate assumed competent enemy engineering, supported by adequate equipment and favorable weather conditions. More realistically, given the onset of spring mud season and the presumed inexperience of American combat engineers, the obstacle could be expected to halt any offensive action until late summer at the earliest. These calculations were not merely academic exercises. German defensive strategy in early 1945 was based fundamentally on the premise that well-constructed obstacles could buy precious time for political negotiations or the deployment of promised wonder weapons that might yet alter the course of the war. Every day that American forces could be delayed represented another opportunity for German research programs to produce decisive technological breakthroughs or for diplomatic initiatives to fragment the Allied coalition. The confidence placed in defensive engineering reflected broader German assumptions about the nature of warfare itself. German military doctrine emphasized the superiority of the trained professional soldier over the citizen soldier, the decisive importance of technical expertise and careful planning, and the ultimate triumph of disciplined execution over improvised solutions. These principles had served Germany well in the early years of the conflict, producing stunning victories against forces that outnumbered German units but lacked comparable levels of training and professional competence. Captain Ernst Hoffmann, one of Weber's section commanders, represented the younger generation of German engineers who had learned their trade entirely during wartime. Despite his relative youth, Hoffmann had already participated in the construction of Atlantic wall fortifications, Alpine defensive lines in Italy, and countless battlefield obstacles across the European theater. His experience had taught him to respect certain Allied capabilities while maintaining confidence in German technical superiority. Hoffmann's particular expertise lay in the development of improvised explosive devices designed to defeat specific American equipment types. His workshops had produced hundreds of specialized mines calibrated to exploit the vulnerabilities of Sherman tanks, American personnel carriers, and engineer vehicles. Each device represented hours of careful work, incorporating lessons learned from previous encounters and intelligence assessments of enemy equipment characteristics. The young captain had also pioneered several innovations in camouflage and concealment techniques specifically designed to defeat American reconnaissance methods. His false minefield markers could create the appearance of dense obstacle belts in areas that were actually clear, while genuine danger zones were marked with innocuous signs that would not attract attention from aerial observers or ground reconnaissance teams. Hoffmann's confidence in his defensive preparations was absolute. He had tested his concealment methods against captured American detection equipment, verified the effectiveness of his explosive devices through careful experimentation, and refined his tactical procedures based on interrogations of American prisoners. Every aspect of his defensive system had been validated through scientific analysis and practical testing. The weather conditions in March 1945 seemed to favor the German defensive position as well. Late winter rains had turned the Rhine Valley approaches into a muddy morass that would complicate any large-scale engineering operation. Heavy equipment would bog down in the soft ground, while foot soldiers would find movement slow and exhausting. These natural obstacles would multiply the effectiveness of human-made defenses and provide additional time for German forces to prepare their positions. Weber had incorporated weather factors into his defensive planning with characteristic thoroughness. Drainage ditches had been positioned to channel rainwater into areas where American forces might attempt to establish equipment parks or supply dumps. Artificial flooding could be triggered at key points to create impassable obstacles or wash out cleared lanes through the minefield. The entire defensive system was designed to work in harmony with natural conditions to maximize delays and complications for any attacking force. German intelligence estimates suggested that American forces lacked experience with the types of complex obstacle warfare that characterized European battlefields. Most American combat engineers had trained in relatively benign conditions within the continental United States, where weather, terrain, and tactical constraints bore little resemblance to the challenges they would face in Central Europe. This inexperience would presumably result in tactical errors, equipment failures, and operational delays that would compound the natural difficulties of the clearance operation. Moreover, German analysts believed that American forces lacked the cultural patience required for methodical engineering operations under fire. American tactical doctrine emphasized speed and aggressive action, characteristics that seemed fundamentally incompatible with the careful, systematic approach required for successful mine clearance. This cultural mismatch would presumably result in either costly mistakes as American engineers attempted to rush their work, or frustrating delays as they struggled to adapt their preferred methods to the tactical requirements of the situation. The psychological dimensions of defensive engineering had also been carefully considered in Weber's preparations. German defensive doctrine recognized that obstacles served not only physical but also moral functions, creating fear and uncertainty among attacking forces that could paralyze decision-making and reduce combat effectiveness. The reputation of German engineering expertise was itself a weapon, creating expectations of delay and difficulty that might become self-fulfilling prophecies as enemy commanders adjusted their plans to accommodate presumed obstacles. Weber had enhanced these psychological effects through careful information warfare. False documents describing non-existent minefield densities had been deliberately placed where they might be captured by American reconnaissance units. Elaborate dummy positions suggested defensive capabilities far beyond what actually existed, while genuine strong points were camouflaged to appear abandoned or insignificant. The entire defensive zone was designed to create maximum uncertainty and confusion among American planners and engineers. The integration of defensive obstacles with fire support systems represented another dimension of German engineering superiority. Weber's minefield was not simply a passive barrier, but an active component of a comprehensive defensive system. Pre-registered artillery concentrations could saturate clearance areas with high explosive shells at predetermined intervals. Machine gun positions commanded observation and fire over all likely approach routes. Mortar teams had prepared firing data for every significant terrain feature within the defensive zone. This integration of obstacles and fires required extensive coordination between engineer, artillery, and infantry units. The type of complex military cooperation that German doctrine assumed American forces could not achieve effectively. The systematic nature of German military training was presumed to provide decisive advantages in situations requiring precise coordination between different combat arms and careful timing of mutually supporting operations. Even the logistics of sustained engineering operations seemed to favor the German defensive position. American forces would need to transport enormous quantities of specialized equipment, replacement parts, and technical personnel to support extended clearance operations. This logistical burden would create vulnerable supply lines and concentration areas that could be targeted by German artillery and tactical aircraft. The defender's advantage in logistics was presumed to be particularly important in operations requiring sustained technical effort over extended periods. Weber had studied American logistics capabilities and concluded that they were adequate for conventional military operations but poorly suited to the specialized requirements of complex engineering tasks. American supply systems emphasized standardization and mass production rather than the technical sophistication required for specialized engineering equipment. This approach might serve adequately for basic combat requirements, but would presumably prove inadequate for the technical challenges of systematic obstacle clearance under combat conditions. As March 15th dawned clear and cold over the Rhine Valley, Major Weber felt justified confidence in his defensive preparations. Every aspect of the situation seemed to favor the German position. The obstacle belt was dense and sophisticated, integrated with effective fire support systems, and designed to exploit presumed Americans' tactical and technical weaknesses. Weather conditions would complicate any clearance operation, while logistical factors would compound American difficulties. Most importantly, the entire defensive system was built upon proven principles of military engineering that had served German forces effectively throughout the war. Weber checked his watch as the first American reconnaissance teams appeared in his binoculars. By his calculations, those scouts represented the beginning of an operation that would consume months of American time and effort. The mathematical certainty of obstacle warfare was on his side. Each mine had to be found, identified, and cleared individually. Each cleared lane had to be verified, marked, and protected from recontamination. The methodical nature of the work allowed no shortcuts, no technological solutions that could simply bypass the careful defensive preparations his engineers had created. The American forces advancing toward Weber's position represented what German intelligence considered a typical combat engineer unit of the type that had performed adequately but not exceptionally in previous European operations. Their equipment appeared standard, their approach conventional, their numbers insufficient for rapid clearance operations. Everything about the tactical situation confirmed Weber's expectations and validated his careful defensive preparations. But as the morning mist began to lift from the Rhine Valley, Major Klaus Weber was about to discover that everything he knew about American combat engineering was not just wrong, but catastrophically, dangerously obsolete. The methodical, individual approach to mine clearance that formed the foundation of his defensive calculations was about to collide with an American innovation that would render 6 years of German engineering expertise irrelevant in a matter of hours. The sound of American machinery growing louder across the valley floor would soon reveal the fatal flaw in Weber's mathematical certainty. He had calculated based on men with metal detectors and hand tools, but the Americans approaching his position had brought something entirely different to the battlefield. The first indication that something was fundamentally wrong with Weber's calculations came at 0847 hours when Sergeant Franz Kellner, positioned in an observation bunker 300 meters forward of the main defensive line, radioed an urgent report that made no tactical sense. American engineers had appeared at the edge of the minefield carrying equipment that Kellner could not identify from any recognition manual or training course he had completed during his 8 years of military service. Instead of the expected metal detectors and hand tools, the Americans were deploying what appeared to be modified agricultural machinery mounted on tracked chassis. These devices moved with mechanical precision across the minefield perimeter, and wherever they passed, the carefully laid explosive devices that had taken Weber's team 3 weeks to emplace were simply disappearing. Not exploding, not being carefully excavated and removed, but vanishing as if they had never existed at all. Kellner's initial report was dismissed by his company commander as battlefield stress or misidentification of standard engineer equipment seen from a distance under poor visibility conditions. Such mistakes were common among forward observers operating under the psychological pressure of imminent combat, and experienced officers had learned to treat unusual sighting reports with appropriate skepticism until they could be verified through additional sources. But within 30 minutes, similar reports began arriving from observation posts across the entire front of Weber's defensive sector. American forces were advancing through areas that should have required days of careful clearance work, moving at speeds that violated every known principle of mine warfare. Worse, German artillery observers attempting to call fire missions on the American engineer units discovered that their carefully pre-registered target coordinates were becoming obsolete faster than firing commands could be transmitted and executed. Captain Ernst Hoffmann, observing from his command post in the village of Niederheim, found himself staring at a tactical situation that his military education had not prepared him to understand. The American advance was following patterns that suggested intimate knowledge of his minefield layout, yet German security procedures had made such detailed intelligence impossible to obtain. More puzzling still, the Americans appeared to be clearing multiple parallel lanes through the obstacle belt simultaneously, a technique that required coordination and equipment capabilities far beyond what intelligence assessments had suggested they possessed. Hoffmann reached for his field telephone to request clarification from battalion headquarters, but the call was interrupted by Sergeant Major Wilhelm Kruger, his most experienced non-commissioned officer, reporting from an advanced observation post near the village cemetery. Kruger had served in pioneer units since 1938 and had participated in obstacle clearance operations across Europe, making his technical assessment of American capabilities particularly valuable. According to Kruger's report, the American engineers were employing some type of mechanical flail system that detonated mines through direct contact rather than attempting to locate and disarm individual devices. The system appeared to consist of heavy chains or cables rotating at high speed, striking the ground with sufficient force to trigger anti-personnel mines while simultaneously marking cleared areas for following forces. The mechanical nature of the operation allowed American engineers to maintain clearance rates that would have been impossible using traditional manual methods. More disturbing still, the American flail systems appeared to be specifically designed to operate under combat conditions. Unlike the careful, methodical approach that German doctrine anticipated, the American clearance operation continued without pause despite incoming artillery fire and small arms harassment from German defensive positions. The mechanical systems were apparently robust enough to function normally even when damaged by shell fragments or small-caliber projectiles, maintaining operational effectiveness that manual clearance teams could never match under fire. Hoffman's mind raced through the implications of what Kruger was describing. If American forces possessed mechanical mine clearance capabilities that operated effectively under combat conditions, then the fundamental assumptions underlying German defensive doctrine were catastrophically wrong. The time calculations that formed the basis for strategic planning, the resource allocations that determined equipment priorities, the tactical procedures that governed defensive operations, all of these systems were built upon the premise that obstacle clearance required vulnerable, slow-moving personnel exposed to defensive fires for extended periods. The telephone connection to battalion headquarters finally came through, and Hoffman found himself speaking to Major Wilhelm Brenner, Weber's immediate superior and one of the most experienced combat engineers in the German army. Brenner's initial reaction to Hoffman's report mirrored the skepticism that had greeted earlier unusual sighting reports, but as similar accounts arrived from multiple sources across the defensive front, the veteran officer was forced to consider possibilities that contradicted everything he knew about mine warfare. Brenner ordered immediate reconnaissance missions to obtain detailed visual confirmation of American clearance methods, but the tactical situation was deteriorating too rapidly to permit careful observation and analysis. German forward positions were being overrun faster than communication links could be maintained, while artillery fire missions targeting American engineer units were proving ineffective against targets that moved too quickly for conventional fire control procedures to engage successfully. Lieutenant Hans Richter, commanding a forward observation team equipped with the latest German optical equipment, managed to establish a concealed position close enough to the American operations to observe their methods in detail. What Richter witnessed fundamentally challenged his understanding of combat engineering and revealed the true scope of German intelligence failures regarding American technical capabilities. The American mechanical clearance systems were far more sophisticated than initial reports had suggested. Rather than simple flail devices, they represented integrated engineering systems combining multiple technologies into comprehensive obstacle clearance platforms. Each vehicle carried its own mine detection equipment, mechanical clearance systems, marking devices, and communication gear, allowing individual machines to operate independently while maintaining coordination with supporting forces. More impressive still was the speed and precision of the American operations. Richter timed the clearance rate of a single American vehicle and calculated that it was processing cleared area at approximately 20 times the rate that German doctrine considered possible for manual clearance operations. Multiple vehicles operating in parallel formations were clearing Weber's entire defensive sector simultaneously, creating not single lanes through the obstacle belt, but broad corridors that could accommodate rapid movement of armored formations. The Americans had also solved the tactical problem of operating mechanical equipment under fire through innovations that German engineers had not considered. Each clearance vehicle was heavily armored and designed to continue operations even when struck by artillery fragments or small arms fire. More importantly, the mechanical systems were configured to operate remotely, allowing engineers to control clearance operations from protected positions rather than exposing personnel to direct fire while working in the obstacle belt. Richter's detailed observations revealed another disturbing aspect of American capabilities. The clearance operation was being supported by specialized logistics and maintenance systems that allowed rapid repair of damaged equipment and immediate replacement of vehicles that became inoperative. American repair teams appeared within minutes of equipment failures, performing complex mechanical work under combat conditions with efficiency that suggested extensive training and abundant spare parts availability. The logistical dimensions of the American operation impressed Richter as much as the technical capabilities. Traditional mine clearance operations required enormous quantities of specialized hand tools, replacement parts for detection equipment, medical supplies for inevitable casualties, and complex coordination between engineer units and supporting forces. The American mechanical approach eliminated most of these requirements while simultaneously increasing clearance rates by orders of magnitude. Sergeant Major Otto Brandt, a veteran of obstacle warfare operations from Poland to Russia, found himself witnessing tactical developments that contradicted 20 years of military experience. Brandt had participated in the construction of some of the most sophisticated defensive positions in German military history, including sections of the Atlantic Wall and Alpine defense lines in northern Italy. His expertise in mine warfare was recognized throughout the German army, making his assessment of American capabilities particularly significant. According to Brandt's analysis, the American clearance operation represented more than just superior equipment or innovative tactics. It demonstrated a fundamentally different approach to combat engineering that emphasized mechanical solutions over human labor, speed over precision, and operational effectiveness over resource conservation. This approach required industrial capabilities and logistical systems far beyond what German intelligence had attributed to American forces. More troubling was Brandt's recognition that the American mechanical systems were specifically designed to defeat German defensive techniques. The flail mechanisms were calibrated to trigger German anti-personnel mines while avoiding damage from the explosions. The vehicle armor was configured to resist German small arms and artillery fragments. Even the operational procedures showed detailed knowledge of German tactical doctrine and defensive methods. This level of technical sophistication suggested that American intelligence services possessed far more detailed knowledge of German capabilities than had been previously suspected. The clearance systems had obviously been developed specifically to counter German obstacle warfare techniques, implying extensive study of German methods and careful analysis of defensive vulnerabilities that German security procedures should have protected. Captain Ludwig Stern, an intelligence officer attached to the 347th Pioneer Battalion, attempted to correlate the tactical developments with existing assessments of American industrial and technical capabilities. Stern had access to detailed intelligence reports on American war production, technological development programs, and military procurement priorities. None of these documents had suggested that American forces possessed the sophisticated mechanical clearance systems now operating against German defensive positions. The failure of German intelligence assessment was more than just incomplete information about specific equipment types. It represented a fundamental misunderstanding of American approaches to military problem-solving and industrial mobilization. German analysts had assumed that American engineering solutions would follow European patterns, emphasizing careful technique and resource conservation over mechanical innovation and industrial mass production. The reality confronting German forces suggested that American military development followed entirely different principles. Rather than accepting the tactical constraints that European armies considered immutable laws of warfare, American engineers had approached obstacle clearance as an industrial problem requiring mechanical solutions. This approach allowed them to achieve tactical results that were impossible using traditional methods regardless of the skill and training of personnel involved. Stern's attempts to develop countermeasures against American clearance systems revealed another dimension of German disadvantage. The mechanical nature of American operations made them relatively immune to traditional defensive responses that relied on inflicting personnel casualties or creating psychological pressure on individual soldiers. Artillery fire that would halt manual clearance operations had minimal effect on mechanical systems, while small arms harassment that could paralyze human clearance teams was irrelevant against armored vehicles operating remotely. Major Weber himself finally obtained direct visual observation of American clearance operations when tactical necessity forced him to abandon his command post and establish a new position closer to the developing battle. What Weber witnessed challenged not only his professional expertise, but his fundamental assumptions about the nature of modern warfare and the capabilities of his enemy. The American operation bore no resemblance to any clearance method described in German military manuals or taught in German engineering schools. Instead of careful individual attention to each explosive device, the Americans were employing what could only be described as industrial-scale processing of the entire obstacle belt. Their mechanical systems operated with the systematic efficiency of factory production lines, converting dangerous terrain into safe passage areas at rates that seemed to violate physical laws. Weber watched in fascination and growing horror as a single American clearance vehicle processed more of his carefully constructed obstacle belt in 30 minutes than German doctrine suggested was possible for an entire engineer company working for a full day under ideal conditions. The mathematical certainty that had underlined his defensive calculations was dissolving before his eyes, replaced by tactical realities that his training had not prepared him to understand or counter. The psychological impact on German personnel was as significant as the tactical implications. Soldiers who had been trained to view obstacle belts as nearly impassable barriers requiring weeks of careful work to overcome were watching those same obstacles disappear in hours. The confidence that came from fighting behind sophisticated defensive preparations evaporated as the defenses themselves proved inadequate against unexpected American capabilities. Corporal Heinrich Müller, a mine warfare specialist with extensive experience in laying and clearing explosive devices, found his professional expertise suddenly obsolete. Müller had spent years perfecting techniques for concealing mines, creating false patterns to confuse enemy engineers, and integrating explosive obstacles with natural terrain features. All of this specialized knowledge was irrelevant against mechanical systems that processed obstacles without regard to individual device characteristics or sophisticated camouflage methods. The speed of American operations also eliminated the opportunity for German forces to adapt their defensive methods or develop countermeasures through experience. Traditional clearance operations provided defenders with time to observe enemy techniques, identify vulnerabilities, and modify defensive procedures accordingly. The American mechanical approach compressed this learning cycle from weeks or months to hours, preventing German forces from developing effective responses. Technical Sergeant Franz Huber, responsible for maintaining German mine-laying equipment and training personnel in obstacle construction techniques, watched the American advance with the growing realization that his specialized knowledge was becoming militarily irrelevant. The careful placement techniques, sophisticated firing patterns, and integrated obstacle systems that represented the pinnacle of German engineering expertise were being rendered obsolete by American industrial solutions that ignored traditional tactical constraints. The implications extended beyond immediate tactical considerations to fundamental questions about the future of warfare itself. If mechanical systems could eliminate the tactical significance of obstacles that had dominated military thinking for decades, then existing doctrine, training programs, equipment procurement priorities, and strategic planning assumptions all required complete revision. Colonel Friedrich Mannheim, commanding the 347th Pioneer Battalion, found himself confronting a crisis that transcended normal military problem-solving. The American clearance operation was not simply a superior tactical technique that could be countered through improved German methods. It represented a fundamental shift in the technological basis of combat engineering that placed American forces in an entirely different category of military capability. Mannheim's attempts to coordinate defensive responses revealed the hopeless inadequacy of German countermeasures against American mechanical clearance systems. Traditional anti-engineer techniques relied on inflicting casualties among exposed personnel or destroying vulnerable equipment through accurate fire. The American systems were specifically designed to resist such measures, operating effectively even when damaged and requiring no exposed personnel to maintain clearance operations. The tactical mathematics of the situation were inexorable and decisive. American clearance rates exceeded German obstacle construction capabilities by factors that made defensive engineering economically impossible. Even if German forces could construct new obstacle belts faster than existing ones were being cleared, the resource requirements would exhaust available personnel in days rather than the months or years that strategic planning required. Private Johann Weiss, a recent conscript assigned to mine-laying duties, represented the human dimension of German tactical obsolescence. Weiss had spent weeks learning the careful procedures required for safe and effective obstacle construction, memorizing the precise techniques that military tradition held necessary for successful defensive engineering. Now he watched American machines casually processing obstacles that had required his most concentrated effort and technical skill to create. The psychological effect on German morale was compounded by the obvious implications for future military operations. If American forces possessed mechanical solutions for obstacle clearance that rendered traditional defensive engineering obsolete, what other military problems had they solved through industrial innovation rather than tactical technique? The clearance operations suggested American technical capabilities far beyond what German intelligence had assessed, raising disturbing questions about German knowledge of enemy capabilities in other critical areas. Staff Sergeant Kurt Zimmermann, a career soldier with 15 years of engineering experience, attempted to calculate the resource implications of American clearance capabilities and reached conclusions that challenged basic assumptions about military economics. The speed and efficiency of American mechanical systems suggested industrial production and logistical capabilities that could support sustained high-intensity operations indefinitely, while German defensive responses required resources that were already critically scarce. The American operation also revealed sophisticated coordination between different combat arms and support services. The clearance vehicles operated with integrated air support, artillery coordination, logistics systems, and communication networks that allowed rapid adaptation to changing tactical conditions. This level of military integration required training, equipment, and institutional capabilities that German intelligence assessments had not attributed to American forces. As American mechanical clearance systems approached the final defensive positions of Weber's sector, the full scope of German miscalculation became undeniably apparent. The obstacle belt that was supposed to provide months of delay had been processed in less than 8 hours. The sophisticated defensive preparations that represented the accumulated wisdom of years of combat experience had proven ineffective against industrial solutions that German military thinking had not anticipated or prepared to counter. The tactical situation was deteriorating beyond any possibility of conventional defensive response. German artillery positions were being rapidly overrun as American forces advanced through cleared corridors faster than defensive fires could be adjusted to engage them. Communication systems were failing as command posts were abandoned under pressure from American units that had bypassed supposedly impregnable obstacle belts in hours rather than the anticipated weeks or months. Major Weber's final radio transmission to battalion headquarters conveyed the essential truth that German defensive doctrine was confronting. The Americans had not simply developed better clearance techniques or superior equipment, but had approached the fundamental problem of obstacle warfare from an entirely different conceptual framework that rendered traditional defensive methods obsolete. Up next, you've got 2 more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out.